Our first speaker is Dr. Liudmila Osipova. Liudmila is a marine researcher at the International Council on Clean Transportation. Liudmila's expertise lies in the analysis of large-scale shipping data and the evaluation of measures related to the environmental and climate impact of the shipping sector worldwide. She is going to talk to us on black carbon emissions from Arctic shipping, a review of the main emitters and time trends. Liudmila, you have the floor.
Thank you everyone for joining the webinar. As Sean already said, my name is Liudmila. I work in the International Council on Clean Transportation as a researcher. And today I'm going to present our work on black carbon emission from Arctic shipping. We're going to look through main emitters in the Arctic and also time trends, because we did similar research back in the days. We have data for starting from 2015, and we had a chance to actually update this data and see what are the trends in the Arctic. So in this presentation, I'm going to walk you through our maps on black carbon emission in the Arctic. And then we look at the different ship types that are main emitters in the Arctic and what kind of fuels that contribute the most to black carbon emissions. And finally, we will look at the changes in black carbon emissions over time. So first, I would like to start with Arctic definitions, because it's not that straightforward as everyone could think. In this map, you see the purple color actually shows the black carbon density, black carbon emission density for 2021. And the lines on the map actually shows different Arctic boundaries depending on the definition. So the geographic Arctic, it's overall the overall color, like this purple color, that shows the geographic Arctic, which is all the area at above approximately 60 degrees to the north. And then we have also the IMO Arctic waters, which is a blue line on this slide, and it's defined at the polar code. And you can also see some other lines, this green and red, that shows the AMAP and AHDR boundaries as defined by the Arctic Monitoring and Assessment Program and by the Arctic Human Development Report. So let's start with the geographic Arctic and look what black carbon emission trends we can see there. So as I already mentioned, this is the all the purple color. It shows the black carbon emission densities in the Arctic. We were able to identify approximately 9,000 vessels in the geographic Arctic, and these vessels emit approximately 1,500 tons of black carbon. As you can see on the plot on the chart to the right, these are the main vessel types that contribute to black carbon emissions, and fishing vessels is the main contributor, while the top three ship types, oil tanker, fishing vessels, and general cargo, responsible for half of the emissions in the geographic Arctic. We can also look into the types of fuels that contribute the most for the black carbon emissions. So on this vertical plot to the left, you see the distribution of the fuel that burned in the Arctic. And as you can see, the main fuel in the Arctic that is the most common one is distillate fuel. And this fuel actually, it's approximately 30% of the overall fuel burned in the Arctic. And then we have on the second most common fuel is residual, which is expected, and then only little part, about approximately 5% of fuel burned from the ship with installed scrubbers. And the least common type of fuels in the Arctic is LNG. Also on the pie chart, you see the actual contribution of different fuels types to black carbon emissions. And as you can see, the distillate is contributing the most as a most common fuel type in the Arctic. You can also look at from both perspectives, which fission vessels and which fuels types are most common ones and contributing the most to black carbon emissions. And this is a top 5 emitters on this pie chart. And as you can see, fishing vessels use mostly distillate fuels and responsible for most of the emissions in the Arctic. And then the second spot, the oil tankers that actually mostly use residuals, and they are the second. Now we can look at IMO Arctic waters and see what time trends were observed between 2015 and 2021. Just as a reminder, it's the same map showing that how many vessels we were able to identify in the geographic Arctic, and the IMO Arctic here is the blue line, as you can see, shows that actually the IMO definition of the Arctic capture only 22% of vessels and 27% of total black carbon emission. And this is excluding actually Baltic Sea because it's not a part of any of the Arctic definitions. So what can we see as a time trend? So these are 2 maps side by side. One shows 2015 data and 2021 on the right side. So as you can see, the fuel use in the geographic Arctic doubled within this time frame, and as well as the black carbon emissions, while the distribution of the shipping and density of emissions look very similar between these 2 years. So we were able to look at how much black carbon emissions still coming from residual fuel and from all fuel, and you see the trend. So through 2015 up to 2021, we observe increase, 2 times increase in black carbon emissions in the Arctic, in the IMO Arctic waters. So the main sort of finding for this study was that residuals are still the most common fuel type at the IMO Arctic and are responsible for more than 60% of black carbon emissions. You can see that within this time frame, the use of residuals got a little bit lower while distillate grew a tiny bit, but overall the trend is that residual fuels are still the most common fuel type in the IMO Arctic and responsible for most of the black carbon emission. We actually did a study showing what kind of benefits we could expect from switching to distillates from residuals in the Arctic. And the benefits, as you can see on the map, these are the most common, we pick up the most common routes, shipping routes in the Arctic. These include just a representative ships like bulk carrier, LNG carrier, cargo ships, cruise ship, and container ships, so all kind of type of shipping that you can see in the Arctic. So we pick up randomly these ships, sort of representing what would be the most common route in the Arctic. And then we recalculated how much benefits we could observe if this ships switched from residuals to distillates. And you see that the switching to distillates it has a huge potential to decrease black carbon emission. It's between 50 to 80% for ships that use residual fuels now, and it can even reach a higher potential for LNG ships, but LNG fueled ships, but they have also other climate issues, like for example, they have methane slip problem, and it has also very high global warming potential. So what is special about this particular representation is that we know that the distillates are available in ports, and actually the ships can switch to distillates overnight if there is a political will to do so, and it can bring tremendous benefits to the Arctic already today. So just to conclude, we find out that in the geographic Arctic, we have approximately 9,000 ships, and they emitted 1.5 thousand tons of black carbon in 2021. And that fishing vessels, oil tankers, and cargo ships are the most common ships in the Arctic, and they're contributing 50% of all emissions, and mainly burning from distilled fuels. While if we look at the IMO Arctic waters, we know that it covers only 22% of these vessels and 27% of black carbon emissions in the geographic Arctic. And the black carbon emission in IMO Arctic waters have doubled since 2015, and the residual fuels remains the most common type of fuel used in IMO Arctic and the biggest contributor to black carbon emissions. So that's all from my side, and thank you very much for your attention. I'm open for any questions.